In this video, we're going to tackle about or discuss about reflection, refraction, and Snell's law. The law of reflection states that the angle of incidence theta I equals the angle of reflection theta r. If a ray of light hits a barrier at an angle, okay, if a ray of light hits a barrier at an angle of theta I, or this is the angle of incidence, then the ray will bounce off the barrier with exact same angle. Okay? As the ray bounces off the barrier, the created angle here is the angle of reflection. Hence, the law of reflection equates both angles, or the angle of incidence is equal to the angle of reflection. Now we have refraction. Light will bend when it changes mediums because its velocity is changed once it leaves a vacuum. When the velocity is slowed, the light is bent toward the normal. When the velocity is increased, it is bent away from the normal. Now let's proceed with the index of refraction. The index of refraction is the value of substance has because of the way it bends light as it travels through the substance. Now we have a list of examples of materials with their respective index of refraction values. Okay, for vacuum, the index of refraction is at 1. For air at standard temperature and pressure, it is 1.003. For ice, it is at 1.31. For water at 20 degrees Celsius, it's 1.33. For acetone, 1.36. For ethyl alcohol, okay, which includes your wine and different beverages, it has an average of index of refraction at 1.36. For sugar solution at 30%, it's at 1.38. For fluoride at 1.433. Fused quartz at 1.426. For glycerin is at 1.473. And for sugar solution with higher concentration at 80%, take note of this, it is at 1.49. If we're going to compare now this index of refraction for sugar solution at 80% with its counterparts at 30%, okay, it has a greater value of index refraction than its counterparts at lower concentration. Hence, at lower concentration, it has lower index refraction than at its counterpart higher concentration. Now, for a typical crown glass, it has an index refraction at 1.52. Now let's define Snell's law. The index of refraction Ni of the incident medium times the sine of the angle of incidence is equal to the index of refraction Nr from the refracted medium times the sine of the angle of refraction. If we're going to state that in a formula, this is in terms of Ni sine of angle of incidence is equal to Nr multiplied with the sine of angle of refraction. Okay? This formula is easy to use. You are either finding an angle or an index of refraction. Now let's proceed with the first problem. A ray of light from an air is incident on plexiglass at an angle of 29 degrees. It is bent at an angle of 35 degrees. What is the refracted index value of plexiglass? Now, in this problem, we're going to use this value for the index of air at 1.003. So why is it 1.003 not at 1.00029? Because air varies with temperature in this problem. It's not at STP. Now let's proceed with the defining the given. value or variables of this problem. Our Ni now is equal to 1.003, whereas we have an unknown value for Nr, the angle of incidence at 29 degrees, okay? So which is the air, whereas the other one, angle of refraction is at 35 degrees, okay? This is the angle as the light was bent from the plexiglass. Now let's proceed with the solution. We're going to use the Snell's law formula at Ni sine of theta I is equal to Nr sine of theta R. Now let's substitute or plug in the values. Ni is 1.003. Sine of the angle of incidence at 29 degrees is equal to Nr multiplied with sine of 35 degrees. This is the angle of refraction. Now, if we're going to further simplify this, leaving the value or variable Nr on the side of the equation. So we have to divide both sides of the equation with sine 35. Now, this gives us with the following form as NR is equal to 1.003 multiplied with sine of 29 all over sine of 35. Further simplifying the following values gives us your final answer at NR is equal to 0.85. Now let's proceed with the second problem. A ray of light from air is incident on crown glass at an angle of 75 degrees. It is bent at an unknown angle. What is the angle of refraction crown glass? Use index for air at 1.003 and 1.52 for crown glass. Now, if we're going to define the following variables or given variables, okay, Ni is equal to 1.003, Nr is equal to 1.52, and the angle of incidence, which is at air, is 75 degrees. And we have to solve for the angle of diffraction of the crown glass. Okay. Now let's use this Snell's law formula at Ni sine of theta I is equal to Nr sine of theta R. Further substituting the values gives us 1.003 multiplied with sine 75 degrees. So that is the angle of incidence equal to 1.52 for the value of NR multiplied with sine of angle of refraction. To further simplify this, we have to use the inverse sign. But first, we have to divide both sides of equation with 1.52. Okay, so this gives us with this form as your angle of refraction is equal to the inverse sine or arc sine of the following values as 1.003 multiplied with sine 75 degrees all over 1.52. If we're going to use now our scientific calculators here, take note that your scientific calculators must be in degree mode as specified in this problem because the given for the angle of incidence is at 75 degrees. Take note, you're going to use degree mode. Okay. Further simplifying the following quantitative values gives us theta r or the angle of refraction is at 39.6 degrees. Now that concludes my presentation for reflection, refraction, Snell's law, and sample problems. Thank you for listening and watching.